invitation, and thank you for an opportunity to reproduce our results. And first of all, we wish to to express our thankful to all countries who support us in our hard events, because you know that now half of our cities after the air strikes, they're without light. So that's why the conditions are a little bit like field conditions. So about our research, first of all, let me say a few words about our university. So where the research was conducted. So it's Odesa National Medical University. It's more than 100 years old. So here it is, you can see our campus. So we have around 6 different faculties. We have 85 departments, more than 6,000 students, and out of them around 1,000 foreigner students. And a lot of academicians. We see more than 100 professors and 400 associated professors. So now coming back to our research that is dedicated to the study of the cytochrome 3A4 polymorphism as a possible predictor of the hepatotoxicity during anti-tuberculosis treatment. So it is well known that the risk of anti-tuberculosis drug-induced liver injury would depend on patients' genotype polymorphism of the xenobiotic metabolizing enzymes, such as cytochrome P452E1 and others. It's well known that the cytochrome 3A4 enzyme is responsible for metabolism for almost 1/3 of all medicines, including anti-TB drugs, anti-tuberculosis drugs. The enzymatic activity of the cytochrome 3A4 greatly depends on polymorphism of corresponding loci, like 1G, 1B. Previous studies revealed that the presence of polymorphic allele of 1G gene during anti-tuberculosis therapy is accompanied by development of hepatotoxicity, while at the same time the region 1B showed opposite relationship, so improvement of the functional state. Therefore, it's promising to simultaneously determine the genotype of both loci 1G and 1B, which finally determine the activity of the cytochrome 3A4 enzyme. So the aim of the current research was to find the meaning of combined detection of 1B, 1G polymorphism in TB patients for the development of the anti-tuberculosis drug-induced liver injury. So blood samples were obtained from 105 patients with newly diagnosed pulmonary TB at Odesa Regional TB Hospital. The detection of 1G and 1B genotype was conducted with the help of the polymerase chain reaction. We have considered medical records of the patients at the beginning and at the end of the inpatient stage of treatment, including the activity of the cytolysis enzymes like alanine aminotransferase, ALT, aspartate aminotransferase, then gamma glutathione transferase, GGT, that's usually tell us about cholestasis, and level of bilirubin that characterize the detoxification function of the liver. The project was conducted according to the declaration of the Helsinki standards. All the patients gave written informed consent and explicitly provided permission for treatment and blood analysis, as well as for the collection of the relevant clinical data. The statistical analysis was performed using the primary biostatistics package with Kruskal-Wallis and ANOVA tests. The chi-square test was used to determine whether there is a significant difference concerning frequency of studied criteria between two groups. Statistical significance was assumed at pH less than 0.05. So here it is, you can see the results. Individuals with homozygous genotype, non-mutated genotype, means patients who didn't carry any mutation in both studied loci, they were considered as rapid metabolizer. Such patients were around 80%, majority. So the patients who carry just one mutation in one of the two studied loci, so they belong to the intermediate metabolizer. So there was 14% such patients. And patients who carry more than one mutated allele, who carry 2 and more mutated alleles, they were considered as slow metabolizer, probably with lowest liver enzyme activity. So at the beginning of the treatment, the highest level of the total bilirubin was observed in the rapid metabolizer, and almost the same level was in intermediate metabolizer. So, and at that time, the level of the bilirubin and AST activity in the rapid metabolizer was 80% more and 40% more than in the slower metabolizer. The normal content of bilirubin was observed at the beginning of treatment, was observed in 100% of all patients with slow metabolizer genotype, while in rapid metabolizer, around 73% of the patients, they have normal bilirubin level. Means at the beginning of the treatment, so the better liver function was observed in the carriers of the slow metabolizer genotype. What happened after the end of the treatment? The same we saw with the activity of the ALT enzyme and AST enzyme. They were the lowest level in the carriers of the slow metabolizer genotype. After the completion of the inpatient treatment with anti-tuberculosis drugs, usually it's lasts 2 or 3 months. If we, in newly diagnosed patients, it's usually 2 or 3 months. After that period of time, the percentage of patients with normal bilirubin in slow metabolizer increased. So we can see that during inpatient treatment, the level of bilirubin in rapid metabolizer significantly drop comparatively to initial level. Initially, it was 13.7 millimole. Initially it was 15.7, and in the end of the treatment, it was 13.7 millimole per liter. So, and in the slow metabolizer, we saw opposite relationship. During inpatient treatment, the level of rifampicin has significantly increased by 43% comparatively to the initial state. The same events happens with other enzymes activity in slow metabolizer. We saw increasing of the ALT level, AST level, and GGT level much more than in other carriers with other genotypes. So, and even in the end of the treatment, we saw that the level of GGT and AST was much higher in slow metabolizer than in rapid metabolizer. So how can we explain that events? So it is known that the bilirubin level in the blood characterizes the detoxification function of the liver. As it mentioned before, at the beginning of the treatment, the highest bilirubin level occurred in rapid metabolizer, while the lowest in slow metabolizer. After the intensive phase of the anti-TB therapy, the bilirubin content decreased in rapid metabolizer, and in the same time, it's increased in slow metabolizer. The specified decrease in the content of serum bilirubin is possibly related to the ability of the anti-tuberculosis agent rifampicin, that is basic anti-tuberculosis antibiotic, to induce the enzymatic function of the liver, which causes a gradual decrease in the content of rifampicin and bilirubin in the blood plasma. At the same time, only in slow metabolizer, the content of bilirubin increased almost in 1.5 times, which is probably related to the lower ability of rifampicin to induce liver enzymes in carriers of such genotype, and that can be evaluated as a possible risk of the future development of the liver toxicity. In general, the represented data indicates that at the beginning of the treatment, there were no significant differences in the liver function of rapid metabolizer, moderate metabolizer between themselves. And much better liver function was in slow metabolizer genotype carriers. After inpatient treatment, a dramatic increase of bilirubin level and activity of the cytolysis markers ALT, AST that were observed in the carriers of the slow metabolizer genotype will prove high risk of the liver-induced toxicity, drug-induced toxicity of the liver that can develop in this category of patients. So in conclusion, we can say that according to the cytochrome 3A4 genotype, after inpatient TB treatment, the risk of the liver injury is more common in slow metabolizer than in rapid metabolizer. That is why the detection of the cytochrome 3A4 genotype in TB patients at the beginning of TB treatment would help to recognize the individuals with high risk of the liver injury who need additional medical care for the prevention of the possible liver toxicity. Thank you for your kind attention. Thank you for the opportunity to represent our results.